Now, polymers are what? Polymers are long molecules made up of small monomers joined together, right? Isn't it? What are polymers? Polymers are long molecules made up of small monomers joined together, right? Now, to see that, this plastic bag, this is also polyethylene, right? See the garden chairs also are polyethylene, right? Isn't it? Isn't it? Garden chairs is also polyethylene. So, how can you make the end product? Both are polyethylene, right? So we have to understand that while making the product of the polymer, we can use different conditions to prepare the end product, what we're doing, right? Isn't it? Just a suggestion to you guys, just a suggestion. When you're doing this, right? Isn't it? When you're doing this particular page, right? Don't try to get confused in the processes we are doing. Processes, don't mix up processes and the type of the polymers. Don't try to mix it up, right? It will be very difficult, right? Now see, now if you're seeing that when we call, there are two kinds of polymers we are getting. One is called as a high density polymer and one is called as a low density polymer. You can very well identify that this is a low density. Because market e to the power infinity. This question will be coming, right? Your school will's favorite part, high density polymer and low density polymer. Garden chair or high density polymer. Just a suggestion to you, just a suggestion. Please note down, while you are comparing high density polymer and low density polymer, don't try to compare with thermosetting and thermosoftening. Please. While you check the IBDB papers, I see that maximum silly mistakes are there. Don't try to, please note down, don't try to compare, ever compare, know where to compare and find a link between high density and low density polymer with thermosetting and thermosoftening. Never. You'll be totally confused. My suggestion. Study this from this book only. My suggestion. Now, how do you make the high density polymer and low density polymer? You are doing polyethylene. You are taking polyethylene. But the conditions you are doing, that will be giving you the different end product, right? Now, in the high density polymer, what we take? We take polyethylene and we add a trace of oxygen, right? Is it clear? We take a trace of oxygen. Sorry, my bad. In the low density polymer, my bad. In the low density polymer, what we do? We take high pressures and traces of oxygen, right? In the low density polymer, what we want to do? We want to make sure that the polymer chains are not coming closer to each other. Now note down this. We learned about intermolecular force of attraction, that if you are making these polymer chains parallel to each other, the intermolecular force of attraction can exhibit, right? And they can pack closely. Note down this. In the high density polymer, we have to make sure that the polyethylene chains are brought closely together so that the intermolecular forces of attraction can exhibit. They can exhibit the intermolecular force of attraction. Clear? That will be making the chains parallel to each other and very, very high density polymer will be obtaining. On the other hand, if we want to make a plastic bag, a flexibility plastic bag, we have to make sure that the polymer chains are randomly broken. Is it clear? This is clear to you? This step is clear? We have to break the random chains. Is it clear? Everybody is clear? Please message me. Please message me. Is it clear? Please message me if it's clear or not. Please message me, everybody. Thank you so much. Thank you so much. Message me, please. Everybody message me. Thank you so much. Thank you. Thank you so much. Please stop me if you don't understand, right? Please message me, please. This is will be coming in exam. This is a very important part. My suggestion: low density, high density. Don't try to get a relation between thermosoftening, thermosetting. Never. What we do in the high density polymer, we make the polythene chain comes closer to each other in parallel chains so that they can come closer and exhibit more intermolecular force of attraction. In low density polymer, what we do, we make sure that we are using high pressures, very high pressures, and traces of oxygen. Why? We have to instantly randomly break the chains so that they cannot come closer. Is it clear? So they cannot pack closely. This is market e to the power infinity, this entire chapter. Do this from this book. My suggestion. Do this from the book. What happens? They don't pack closely. And we get a low density polymer. Clear? In the high density polymer, we do at a very reduced pressure. We don't have to use a pressure. Slightly high raise pressure, 50 degrees centigrade. And all the chains will be packing closely, right? Isn't it? And hence we are getting a high density polymer, right? Is it clear? Clear, everybody? Now, I told you, request to you, as an examiner, I'm telling you, don't try to compare. I'm telling you, it is devastating. Many brilliant students try to compare, who want to learn chemistry more. They want to compare. Let's compare. No, never compare. Thermo-softening and thermosetting. This is a separate kind of approach we have to do. What is thermo-softening? As the name suggests, thermo-softening. You can take the example from the name. When we heat it, thermo means heat, it softens. And again, we can reset and it hardens. Thermosetting, see, if you use heat, it does not melt them. Is it clear? That's the difference. So thermosetting and thermosoftening polymers. In thermosoftening polymers, what is the thing? In the thermosoftening polymers, we can easily softening it. You can easily soften it, and we can reset it after cooling down. In thermosetting, the polymers do not melt. Why? We have to understand why. Why they do not melt, right? When we heat them, right? Now, the cause is that in thermosoftening, we are taking a entangled web of polymer chain, right? Like this. This is very important, right? In a thermosoftening polymer, we are taking entangled chain, see, and thus the intermolecular forces of attraction are weak. Is it clear? Simple. Intermolecular forces of attraction are weak. We are taking entangled web. They are not parallel. They are not parallel. They are like meshed. So the forces of attraction between the polymer chain are weak. Is it clear? When we heat it, what happens? This weak intermolecular force of attraction can easily break, softening it. And when we again harden it, what happens? It will be setting it. Now, in the thermosetting, what we do? In the thermosetting, we are intentionally putting a covalent bond in between the chains. This is very important, right? We are intentionally putting covalent bonds in between the chain. Is it clear? And while doing intermolecular force of attraction, can you recall? We learned that one chlorine is attracted with another chlorine by weak attraction forces. This is called as intermolecular force of attraction. I told you also that when we melt or boil, we break the intermolecular force of attraction. We break this. Covalent bond we cannot break. Covalent bond will be taking 800 degrees centigrade to break. Is it clear? Covalent bond is extremely strong. In the intermolecular force of attraction chapter in C3, you learned this. The intermolecular force of attraction is the attraction between two molecules. And by nature, it is weak in nature. So similarly, a covalent bond is already there. So it cannot be broken. Is it clear? We put covalent bonds in between this, right? We put covalent bonds between the polymer chains. The covalent bonds are so strong, they will not break on heating. Is it clear? Is it clear? Where do we use thermosetting? Thermosetting we are using in the same thing. We are using where? Thermosetting we are thank you so much. Thank you so much. I hope that this is helpful, this session, right? Might be your school might be taking 12 sessions to cover this. I'm covering this part. Please, if you want to say thank you to me, just make sure that you go to the revisions as per I've guided you. Wherever I've told you that go from E to the power infinity, whatever book I'm told you, do from this book. Make sure that paper number 2, the C12 to C15, this chapter, now do it very well. Is it clear? So we are taking a thermosetting. See, this is thermosetting, right? So it sees that we get heated up. Does it melt? It does not melt. So this is an example of a thermosetting polymer we are using. They are using covalent bond in between them, right? And in thermosoftening, we are getting an entangled web of chains. Fine. Is it clear, everybody? Right? Fine. So this is the thing we have to know now. If you see that, now we are going to the part of glass and ceramic. Few minutes left, right? I know that. Please do. I'll be joining with you also, right? Next week. You don't have to join in the regular sessions, right? I'll getting a break to you, right? No, what is glass? Glass is what? Glass is actually what? SiO2. SiO2, silica, right? Silica, SiO2, glass. Whatever glass you're having, right? Now, in the glass, we have to understand that glass can be two types of glass, right? One is called as soda lime glass, and one is called as a borosilicate glass. Is it clear? Isn't it? Glass can be of two types. According to the uses we are using, it can be soda lime glass, it can be borosilicate glass, as per the uses. In the soda lime glass, how do you prepare the glass? In the both the processes, what we do, we take the silica from the sand. We get silica from the sand, right? Sand. And have you seen in the sand, when it is dry sand, some glittery things are there, something glitters inside the sand? That is silica, right? Indeed, that is silica. That you have to extract. Sand, all complete sand is not SiO2. The glitters which are there, that is silica. We take silica and we do what? We take silica and we add limestone to it, right? Limestone is what? Calcium. See, soda lime. Lime is what? Lime is calcium carbonate, right? We add lime, calcium carbonate, soda lime glass. So calcium carbonate. And soda is what? Soda is sodium carbonate, right? You have to remember these names, right? Nicknames. You might have got nicknames, school name and nickname. So limestone is the nickname of calcium carbonate. Soda lime, soda is what? Soda is Na2CO3. We take SiO2, we take calcium carbonate, we take Na2CO3 and we heat it. And we heat it at 1500 degrees centigrade. They react with each other. Now, after that we cool it. Now, this thing you have to know. After that we cool it. When we cool it, what happens? Glass turns to a solid. Now, this is a very shocking thing. This will be not in a regular lattice. This is a very important. They are not in a regular pattern. This thing you have to know. Right? Now, the second type of glass is what? Borosilicate glass. Borosilicate glass, what we're taking? You understand this. Soda lime glass we are using in the glass we are drinking water. There are some glasses which we put in the oven, right, to cook that particular paneer roast and all, paneer roast, vegetable roast. So it has to withstand heat, huge amount of heat. There we cannot take soda lime glass. What we take? We take borosilicate glass. In the borosilicate glass, what we take? As the name suggests, we take silica and we add boron trioxide, right? Clear? BTO3, isn't it? We have silica, we have boron trioxide, and we heat it. And it turns to borosilicate glass, right? Now, we come to the part of ceramics. What do you mean by the word called as ceramics? In the ceramics, what do we do? In the ceramics, we are taking clay. What is ceramic? Ceramic is nothing but it is made from clay, right? Clay. Now clay, you should understand this. This part you mark it into the part infinity. This page number 226. This part goes slow. Don't hurry up. Have you seen clay is slimy when it is wet, and after that when you heat it, it hardens up. Why? Now this thing you have to know. Clay contains what? Clay contains metal compounds such as aluminum and potassium, right? And non-metals also, right? With ionic bonding, right? Is it clear? Now when the clay is wet, what happens now? This thing you have to understand. When the clay is wet, the ionic compounds in clay, right? They are separated by water molecules, right? They are not able to come closer, the ionic compound. The water molecules is in between the layers, right? Clear? In the clay, it contains mud and it also contains metal such as aluminum oxide, non-metals such as silicon oxide, right? Potassium oxide, ionic compounds. When the clay is slimy, the water will be separating out the two layers of the ionic compounds, right? Not allowing them to come closer. So thus, wet clay is having water molecules in between the layers, right? And it's slimy. Now, when you take clay, wet clay, and you take in the shape of a pot by the potter's wheel, right? I have just seen that how the potter's wheel, wet clay. And after that, what we do, we put it in a furnace. When we put it in a furnace, what happens? The water molecules is driven out. This is thing you have to understand. Water molecules is driven out, completely driven out. They're driven out. When the water molecules are driven out, what happens? The layers now come closer. Now see, can now exhibit ionic bonds in between the layers, right? Making it harder, right? Much harder. But clay, this ceramics has got a negative point. What's the negative point? It will be shattering. Ceramics are brittle, right? A sharp blow can distort the layers, and thus it is what? Thus it can be brittle. Clear? Composites, my suggestion, composites you have to study from the CGP book. Just 1 minute. Give me 1 minute. Little bit of time left. I know that you are helping me. This finite renewable resources do from CGP. This reuse, recycle, right? Composites. You can do the C12 to C15 from the CGP book also now, but after the exam you go from the book. But whatever told you, e to the power infinity chapters, you go through it. Yesterday one student asked me, right, matrix, right, that part. Composites are made up of one material embedded in the another material, right? This is fun, right? It contains two divisions. One is called as the matrix or the binder, matrix or binder. And in the matrix or binder, we add fibers or fragments inside it, right? Isn't it? Fine. So what are the composite you have in your course? Is it clear? Composite contains a matrix where the fibers or the fragments are embedded in it. It will be giving a reinforcement. Why the fibers are added? It gives a reinforcement, right? What are the examples you're having? We have got fiberglass. In the fiberglass, what you are having? In the fiberglass, we are having glass fibers embedded in a polymer gel, right? We take the polymer gel and we add glass fibers to reinforce it, right? Clear? So it is used in what? Skis, boats, surfboards. Now come to the second composite, carbon fibers. In the carbon fiber, this also contains a polymer matrix, and on it we have got carbon fibers which are there, right? Right, carbon fibers we're adding. Simple, right? The plus point of this what? The carbon fiber composite, they're very light, yet very strong, 100 times stronger than steel. So we are using aerospace engineering, sports car manufacturing. Third composite is concrete. Concrete contains what? Concrete contains, suppose you know that the matrix is what? The matrix is the cement, right? Cement is a matrix. And what are the fibers we are adding at the fragments? The sand and the stone chips, right? Clear? Easy, right? It is used in building materials. What is wood? Wood contains cellulose fibers. Wood is a natural composite. I forgot to. These are man-made. Wood is a natural composite made by God. It contains a organic polymer matrix, and inside the organic polymer matrix, you have to have fragments or fibers, right? It contains cellulose fibers, right? Isn't it? Inside the matrix, right? Clear? Fine. So thank you so much, everybody. It's a marathon session I did, right? John, send me a message, please. C 14.2, C 14.3, C 14.4, C 14.5, C 15.3, C 15.4, and ammonia and making of ammonia. I've already done it already in the last session, right? Those who have not, there is 2 students who missed the session due to some work in the school and some other activities. So go to the videos which are sent to you, right? The equilibrium will be coming in your exam, right? In the next session when I join, I'll be covering, please try to type out, John, in the next session, C 15.7, 15.8, and C 13 I'll be covering, and paper 1 I'll be covering, right? Fine, everybody.